Okay, now let's us discuss about more detail in Arduino input and output. And in this video lecture, I'm going to show you a few examples on how to use the input and output port in Arduino, and how you can do the programming to operate this input and output. And before that, okay, before we go further, okay, I would like to give you some I think this function have been give to you, or have been exposed to you in the previous lecture when I show how to do some LED blinking. Of course, this is actually the function, some of the important built-in function in Arduino that you need to familiar in order for you to operate the input and output port. Okay, for example, there's a one function there, pin modes. Okay, this function is, the purpose of this function is to reset. Okay, you need to set this pin mode function in order for you to operate the input output mode, input output port. Because the pin mode function, okay, the purpose of this function is to set in order to determine whether the selected pin is used for input or output. So again, that's why I said yes, most of the Arduino port you can assign at one time. You can assign either you can use it as input or you can assign as the output. In order to select this option, then you need to run this function, because this function will set the port for you, whether you want that port to become input or that port to become output. And then we have also a digital read. Okay, digital reads, once you have set a certain port as a input port, okay, especially digital input port, okay, by executing pin mode function, okay, then you can use digital read to read the value from the outside to that port. Okay, that you can done by using this function digital read. Okay, the purpose is to read this digital signal from the outside through the selected pin that you set in this function later. And if you set your pin mode, okay, if you execute your pin mode and you assign certain certain port as the output, then you can use a digital write function for, you know, to write to that port, and actually that port will send the signal from the Arduino to the outside. Okay, that is, you set the port as the output, as the output port. Okay, and then you also need to familiar with some I can consider as a reserve word or constant. This is a built-in constant inside the Arduino, where you can use to represent the 0 or 1 or 0 or 5 volt, because of course we want to have some user-friendly code. Instead of you set by using figures or using numbers, then we can use this word, because this word we represent, if low, then that represent 0 volt or 0 in binary. If you put high, that is represent the 1 in binary, or 5 volt if you talk about the real digital signals itself. Okay, just make sure that you familiar with this function, because this is the function that you need to use in order for you to design or to set or to operate your input and output port in Arduino. Okay, in order to discuss this one, let's go back to our similar example that we have discussed before, which is LED blinking. Okay, you can see here. Okay, this one is a little bit different from the previous one. Okay, as you can see in the previous slide, okay, we are using, you know, okay, here yeah, in order for us to apply the blinking LED, Okay, let's I show you the previous example in Tinkercad, which is this one. Okay, when we run this code, of course it will do LED blinking by utilizing this built-in LED. Okay, but actually LED underscore built-in is a reserved word in Arduino library that is referred to this LED, or you can also say that in other words, in if we talk about the Arduino board itself, this LED is actually is also connected with pin number 13. Okay, so if you, let's say I stop this simulation. Okay, I stop the simulation and then I change this LED underscore built-in with number 13. Okay, which is refer to this port. Okay, because if you put it 13, it refer to this port. And of course, again I replace this LED built-in with number 13. All LED underscore built-in I replace with number 13, and then I run back the simulation. Okay, you still can see the built-in LED is keep blinking. So why is this happen? Again, like I said, the Arduino board itself, actually this if you refer to the schematic diagram, this orange LED, or it is referred as a built-in LED, is actually is connected with this pin number 13. So if you change this or process to pin number 13 as well, this LED is keep blinking. Okay, so that is one of the things that I want to highlight, because if you can see over here, okay, but however, if you change to another port, okay, let's say I change it into 12. Okay, I stop my simulation and then I change it into 12, which is referred to the neighbor port here, D12. Okay, if I run the simulation, now the LED is not blinking. So why is this happen? Again, now the operation of this signal actually is at the port number 12, where it does not connected with this LED. This LED, built-in LED inside this Arduino board, is only connected with with this port number 13. Okay, so again, don't confuse when we want to discuss this next example, which is LED blinking. Now we are using LED 13, and again now we want to show, I want to show to you, instead of utilizing this built-in LED to do LED blinking, we can have external LED to show that that function is working. So this is one of the simplest digital output example that I can show to you. So it's LED blinking. So now let's we simulate this one and discuss the function that involved here. So again, we have a review on this slide. What are the function? Now we want to discuss about that function. As you can see here, okay, so again, I hope you already understand what is the difference between setup and loop. Setup is the first function will be run by the CPU, and it will run once. Okay, but for loop, any instructions inside the loop, it will be executed many times. It will continuing and repeating forever, so it will not stop. Okay, so and then again you can see that pin mode. So what is the function, what the purpose of pin mode is to set, okay, you whenever you want to use any port, you must first apply this function first, pin mode, because this is the one that you want to set. Either you want to make it to become an input or output. in this example, I choose pin number 13, so pin mode number 13, so my pin number 13 I set as output. So that is how to use that function. And of course, in general, you must put this function inside setup function, because this one in general you need to run it once. You don't have to run it forever, or you don't have to do a repetitive uh, mechanism to execute this one, because you only want to execute this one time. So that's why you put it in the setup. And then in loop function, you using this function, which is digital write. So again, digital write is to send or write a digital signal to the outside, meaning that from the Arduino you want to write on to the outside. So of course, this can be used if you choose the port, or you set the port as the output. Of course, if you see over here, we already set our pin number 13 to become output. So that's why you can use digital write function. So then inside this function digital loop, you apply digital write, you set the port that you want to write, okay, which is number 13, again number 13, and then you set at high for 5 volt or 1 in binary, and then that will make this LED turn on. And then I already discussed this one, delay for 1 second, and then you turn off the LED by you write to the pin number 13 0, which also make the Arduino to generate 0 volt at this port. Then that is because that is why the LED is turned off, and then you delay 1 second, and you are keep the loop function will keep looping forever. Then it will execute line by line around this thing. Okay, so again, let's go to this slide, which is I can discuss it a little bit more detail on how the circuit works. But this one you need to remember or recap back all the knowledge in your digital electronic as well as circuit theory. Okay, so when you okay, okay, so whenever you first you set this one, okay, so pin number 13 here will become output port. So output port will not reading signal, okay, output port will not reading signal from the outside, but it will generate signal to be sent to the outside. Okay, that's the purpose of output port. Okay, so that is happen to the pin number 13. So whenever you apply digital write high, actually in circuit theory it will become like this. Okay, 5 volt. Okay, that is happen when you apply digital write. But when the program when you apply digital write with pin number 13 and high, but if you apply digital write again pin number 13 low, so it will become like this. Okay, it will become like this. So this is referred to high, this is referred to the low. Okay, so doesn't matter any port around here. If you choose 12, if you put digital write 12 high, then it become 5 volt, and if you put digital write 12 low, it become ground, something like this. So means that whenever this one is keep looping, this one is keep changing, either become 5 volt or it become ground. 5 volt delay, ground, delay 1 second, 5 volt again, delay 1 second, ground, 1 second, so it will keep changing like that. So that is happen in if you talk about, if I want to, you know, to make a terminology in terms of circuit theory, that is what happened to the port 13. So meaning that of course if you talk about just signal, it's actually 5 volt, delay 1 second, and then it become 0 0. Okay, this is 5 volt, this is 0, so the same things. Okay, so then imagine that, okay, imagine that if you connect, okay, if you connect, I just try to change the color so you will not confuse there. Imagine that this, the same port, you connect with wires. Okay, you connect with wires where the wires is connected to some resistance, and then you have the LEDs there. Okay, LED. Of course, you connect the other lead of your LED to the ground. So what will happen? What will happen there? So let's say I discuss about this one, digital write 13 high. So if I take this circuit and I separate it into this area, so it's look like if you apply digital write pin number 13 high, then it will become like this. But if you execute digital write pin number 13 low, then it will become something like this. Okay, so if you see the circuit here, if you draw back with you know, proper with proper circuit theory schematic diagram, okay, you can imagine the circuit is equivalent to this circuit. Okay, you have 5 volt, then you have ground, you have a resistance, you have the LEDs. Okay, so that's why when there's a battery there, there's a 5 volt there, of course this LED is turned on. Okay, it's on. But how about this one? For this one, so if you draw in a proper way, it seems to be like this. Okay, because there's no power there, that's why the LED is off. So that's how you can use it to you know, by using the digital output pin, a digital output port in Arduino. You can one of the simple example you can do is by controlling the LED turn on and turn off, because that is how we apply. One of the example that you can you know, you can know how actually you can apply the output, digital output in Arduino. Okay, in this example we are using pin number 13. So that is back to this example there. Okay, back to these examples. So that's why we are actually you can see that we have one lead going to the outside this port, we have a resistor, we have a LED, and then we go back, connect to the ground. So this is equivalent to this connection. Okay, you have wires going to the resistance, going to LED, and going back to the ground, because by doing that, then these two digital write function will change, either it become 5 volt or it become ground. That will make this LED turn on and turn off. Okay, so let's show the proof through to the Tinkercad there. Okay, you have this one, and then I already stopped the simulation. Okay, and then just close this code first, and then you take the LEDs. Okay, make sure the anode is connected with, okay, positive is the anode and negative is going to ground. Sorry, you must connect the resistance first. Okay, resistance doesn't matter the value, you can have maybe small value, so the LED will have to maximize the brightness of the LED when turn on, then you need to have a low resistance value. In general, let's put it to 0 ohm. Okay, just connect, then you connect here, and then this one you connect to the ground. So, and then you go back to your code and make sure it's 13, because I connect with the 13, so now we are using pin number 13. So the first function, pin mode function, we want to set the port number 13 as output, and then after we set as the output, then we can utilize the digital write. Okay, whether you can make it high or low. Okay, 1 or 0, or 5 volt or 0. Okay, if I run this simulation, okay, you can see the LED is blinking, and the built-in LED as well is blinking, because pin number 13 is connected with this one. Unless if you want to use to apply the same example on the other port. Okay, let's do that. I change it into pin number, let's say I put number 8. Okay, if I run again, of course LED is not blinking, because now you don't do nothing at this port. So in order for you to operate pin number 8, then you need to change this one into 8. Okay, as I set the 8 port as the output, and then you do digital write to the pin number 8. If you run the simulation, and it keep blinking, now the built-in LED is not blinking because we are not using LED number 13.